Hey, good morning, everyone. So, my name is Edward Doan, and I'm a customer engineer with Google Cloud, and excited to be here. I'm based in Austin, Texas, where I've been at Google for the last 9 years. I'm also an adjunct professor at the University of Texas at Austin, so I speak your language too as a fellow academic. And so today I want to talk a little bit about Google Cloud Platform as an enterprise platform. All right, guess the emoji. Anyone ever played this game, or you have kids who've played the guess the emoji game? So today is World Emoji Day. It's an unofficial holiday. There's a world unofficial whatever day for everything, right? So World Emoji Day, and we'll talk about cloud computing. All right, so first, the good news. Google Cloud Platform is now a thing for the UC system. So in May, the UC Office of the President and Google Cloud came to an agreement, and now we are blessed and ready to go in your respective campuses. There's a HIPAA BAA. All you got to do is you or someone from your campus fill out an order form, send it to our account exec, Sarosh Nassim, and we'll get you started. So what exactly are we going to talk about today? So I want to talk a little bit about how Google Cloud can be a part of your hybrid or multi-cloud story. Talk a little bit about cloud migration, what that looks like. Touch on HPC, and then finally big data. So hybrid and multi-cloud. So turns out that cloud computing, we've been talking about it for the last 10 years, maybe even longer if you count all the computer, the network is the computer. I think that's what Larry Ellison said back in '97, right? We've been talking about it a long time. But it turns out that from a practical perspective, some of the trends that we're really seeing in 2019 are this notion of hybrid cloud, so combining your on-prem infrastructure, even a private cloud if you're running it, with public cloud infrastructure, and also multi-cloud. Just like in a lot of the other procurement scenarios you're involved in, you don't necessarily want to be single sourced. You want to be multi-sourced to ensure that you're getting best of breed products and also to ensure price competitiveness between providers. So enter multi-cloud. Other trends you see up there, microservices, DevOps, CI/CD, orchestration. A lot of these new development trends are being supported by Kubernetes and containers. How many of you are familiar with Kubernetes or using it today? Okay, so a handful. So what is Kubernetes? And maybe I should even step back a little further. What are containers? Containers are the embodiment of the write once, run anywhere concept that this nirvana we've been promising in computing for so long. And I think we're really right there. The ability to take a container, which is your application code and any libraries or dependencies, have that developed on a workstation or laptop, and then bring it into a server data center environment or even to the public cloud, all seamlessly without needing to make changes to your code. That's what containers promise us. And Google really was one of the early inventors and adopters of container technology. Gmail is powered by containers, for example. And Kubernetes is the orchestration system that underpins these containers. And so it's the ability to have containers be abstracted away from the VMs or physical hardware on which they're running. That's what Kubernetes is going to bring for you. And so, for example, if you've got an application for, let's say, student registration, and beginning of the semester or beginning of the quarter, you're going to see a spike in your workload, rather than you having to dedicate specific VMs for that application, you can allow Kubernetes to handle the scale up and scale down of the application based on inputs, the amount of incoming requests, and based on the resources, so the min and max number of nodes that you've allocated to the application. And the idea is to really abstract the infrastructure away Kubernetes is, it's configured using YAML files. And so we're now getting into this notion of infrastructure as code. And you're going to manage your infrastructure just like you'd manage any other software artifact. So you check in and check out config changes for infrastructure just like you would for application code. So bringing in that discipline is going to help reduce the tight coupling between hardware and software. And so then you're able to, for example, if Google Cloud offers the best pricing or performance at a given time versus on-prem or versus a different cloud, you're able to make that seamless transition all using code. All right, and so that the hybrid and multi-cloud story is enabled by this new thing that Google just announced this past spring called Anthos. So Anthos is taking the Kubernetes and container paradigm one step further and saying we're going to have this layer that allows you to run containers in GCP, AWS, Azure, or on-prem, and have it all federated and managed through a single pane of glass. That's pretty cool, right? And so you're able to then move your workload between clouds, or you don't even have to think about it yourself. You can just set the thing on autopilot and run. So based on some parameters, right? Like if you're going to exceed 100 cores of on-prem, then let's flow that traffic into Google, for example. And so being able to manage all that at scale through a single interface. Oh, and by the way, if your devs are pushing a new update to the application, let's do maybe an A/B test or canary deployment on-prem first, and then leave the cloud side on the previous known stable version, for example. Really enables these kinds of new workflows that allow you to be more flexible and more agile in your development and deployment processes. And so yeah, I talked a little bit about this. I should also mention Apogee, right? Talked to some folks from UCLA. Do we have any UCLA folks here today? Maybe, maybe not. Oh, okay. They're around, maybe just not in this session, but they're looking at Apogee as a way of doing API management in order to connect legacy applications. I keep hearing about this path thing. Every time someone talks about path, yes, that's the reaction I get. Okay, so connecting legacy applications and bringing them into the modern world using not RESTful APIs that can also be monitored and secured. And so that's what Apogee brings you, and that's what the folks in LA are looking at. So, okay, this is all well and good, but how do we actually connect multiple clouds together to enable something like Anthos? Or if you've got a certain business application running happily in AWS and you want to bring in a new application in GCP, how do we actually connect those? So turns out that the multi-cloud network connectivity story is actually not as hard as we all thought. You have an Amazon VPC or a Microsoft Azure project, you can connect over to Google Cloud, a VPC in Google Cloud, through something like a VPN connection between the clouds or a dedicated interconnect. I think Amazon calls it Direct Connect, Microsoft calls it Express something. But the idea is you can then connect these things make connections between clouds or connect back to campus. And so if your campus network is 10.1.0.0, you can extend that RFC 1918 space up into Google Cloud. So Google Cloud can then be 10.2.0.0 and have all the traffic talking to each other as if the cloud is an extension of what you've got on-prem today, and ditto with the other public clouds. So all of this, the point of this is to really make it possible for you guys to have more flexibility in your IT environments and not just be constrained to what you've got on-prem today or this public cloud that you might have gotten into a few years back. So let me touch on migration to the cloud. So for a lot of folks, it's kind of a big jump. Anyone feel this way? It's a big jump. We're talking about cloud. The industry's talking about it. All your friends in enterprise and private sector tech are talking about it. But to actually do it, right? And we're not talking about like the cloud native folks like Pinterest or Snapchat or DoorDash, whatever. We're talking about like a business an enterprise like yours that's been running for decades now. How do we actually make this transition? Well, it turns out, like anything else, and you all have been in the enterprise a long time, it's a stepwise process, right? We do this incrementally. And so assess, pilot, move data, move applications. Now, the first part is assessing. So taking stock of what you've got. And I like to bucket these into easy things, right? Let's do the low-hanging fruit first. Harder things, maybe this can be a phase 2, and then stuff like I can't, right? And I'm an engineer, so I'm not going to be the marketing person that tells you, oh, you can move everything into the cloud. No, I would be betraying the trust of my fellow technical folks here if I said that you could move everything. But no, it turns out that it's quite possible to bucket everything into these categories, though. So things that are easy, anything that's running in a VMware environment, for example. If it's a Linux application running on x86, there's a good chance you can move it to the cloud, right? Things that are a little bit harder, if you've got some workloads that have a compliance requirement that maybe public cloud is not yet there to handle. That might be a little bit harder. We can certainly work on it, but it's not something that you can do. You can just flip a switch and do tomorrow. And then finally, things that you can't. Any kind of specialized hardware or software that requires a specific license to run on-premise. Or, if you've got green screen applications today. Anyone still using mainframes that you see? Yeah, maybe. Okay. I can tell you that UT Austin embarked on the HR system going from mainframe to Workday. I think that's been 6 years in the making. It's still not perfect. So the next step, once you've made the assessment, is to prep for the pilot. So things like figuring out what skills do you have today versus what do you need in order to go to cloud. And that's something that Google is very happy and willing to help out with. If you've got strong interest, I'm more than willing to travel to your campus to help your team learn about Google Cloud or containers or putting Node.js into cloud functions, for example. Identifying process changes or any governance process changes that might need to happen as a result of going to cloud. These are all things that you might need to consider as part of that prep process. And then next step, so rather than moving applications first, I actually like to move data first. So some of you, have any of you done like an Exchange to O365 or Exchange to G Suite migration? Some of you? All right. So my background coming to Google 9 years ago was to move Lotus Notes over to Gmail. And so my background as a Lotus Notes engineer and going into Gmail, the best practice that we'd come up with was to always move your data, your mailboxes first, and then move the users over to the new application. And the reason for that is because it turns out that, although data is dynamic, there's a big corpus of data that is, I'd call it historical. And you can move like stuff that's older than 30 days into the cloud environment without really harming the dynamic production environment. So you do the legacy migration first, and then we can catch up and do a sync of any new changes on your data. And then after that, once we know that's good, then you move the applications themselves, whether that's going from Lotus or Exchange over to Gmail, or going from an on-prem legacy, say a .NET application to a more modern web application, moving the application next and being able to test it in the cloud, that's sort of the next step. And then finally, doing this lift and shift of applications. One pattern that I see often is to create a mirrored environment. And so you're doing like and like. So you could be running your custom application in the cloud and on-prem. And guess what? A lot of people just keep those two environments running simultaneously because now you've set up a high availability or DR scenario for yourselves. So, okay, that's kind of cool. But if you want to go fully native in the cloud, once you've done that mirroring and you've done the testing, UAT, make sure everything's the same, then you can decide on when to cut over. Pro tip, don't do application cutovers on Friday night. Could make for a long weekend. But you can do it in stages if you want, or again, with containers, for example, doing these canary deployments or an A/B, moving a little bit at a time so that you minimize impact and risk. That's another strategy. So that's moving the application. And then finally, step 5 of migrating to cloud, it's possible to optimize your application. So moving from VMs over to platform as a service, for example, or moving fully to a serverless environment. This is starting to become more popular, whether you're developing in AWS Lambda or Google Cloud Functions. I'm starting to see a lot more development in these serverless environments just because especially from a DevOps perspective, spending less time doing the IT admin stuff is going to help everyone be more productive. Cool. So let me touch a little bit on HPC in Google Cloud. So what I've seen, so HPC, turns out it's a real popular workload. How many of you guys support HPC for your users? Handful. Good. All right. So this is really hits at the research mission for academic institutions. HPC, you kind of have a taxonomy of 2 different types of workloads: high throughput computing and what we call high performance computing. High throughput computing, turns out a lot of the big compute jobs that you may see from a PI or other researcher, they say they need InfiniBand and they need gazillion cores, and they want the biggest, fastest HPC cluster in the world, right? But it turns out they may actually have a massively parallel job that would be more like high throughput computing. And in that regards, having access to lots of cores, lots of GPUs that are all working on a small task independently, cloud is surprisingly good at that. High performance computing, where you have more tightly coupled jobs, your things like simulating the interaction of mouse brain neurons, or some computational fluid dynamics to optimize an airfoil for low drag. These kinds of jobs turn out to be very good at running in your traditional HPC clusters, stuff like that at SDSC or any of the other national labs or Exceed clusters, etc. And so where Google Cloud can really help you out is, instead of having a single queue with users lined up to get access to scarce resources, right? The one cluster. And if you have how many of you are familiar with workload managers in HPC? Yeah, there was a talk yesterday about this topic. And instead of having just a single queue for users lining up to get access to compute time on the cluster, we're proposing setting up a separate cluster for every single user. And so now high throughput computing, massive clusters, no longer becomes a scarce resource that people have to get time on. You can just spin up your job, run 200,000 cores in parallel, for example, and then spin down the cluster when you're done with the research. And so if you think about that from a research and scientific computing perspective, now your PIs don't have a resource contention problem. So that's a benefit of cloud. Auto-scaling. Suppose you've got a cluster that, this is similar to what I was just talking about, multiple queues or multiple clusters, but you can also auto-scale if you have a persistent cluster or you've got an existing cluster on premise. You're able to use cloud as a way of scaling your resources on demand. And so let's say you've got a cluster, this beautiful cluster, maybe a year old, 4,000 cores on it, but you've got only 100 GPUs, and you've got a researcher who needs 150 GPUs. Well, the ability to scale, if they're able to break up their workload into discrete tasks, and then being able to scale into the cloud will enable them to do a job that might not have previously been able to fit into the on-prem cluster in the past, right? This is, maybe a way of thinking about this, I guess, is if you've ever needed to move furniture, being able to move stuff in your SUV or in your truck, but then being able to go to Home Depot and rent the additional big truck to move that extra long sofa that wouldn't otherwise fit into your car. This is that equivalent. And then, federating to cloud. So if you do have an HPC cluster that's using Slurm, which is one of the popular workload managers, we're able to make Google Cloud look like an extension of your cluster. And so to the users, all they see is, big fancy supercomputer cluster, and they don't necessarily need to know that, half of it is running on-prem and the other half is in the cloud and only spins up as necessary. So this is a cool capability that SCED-MD, the makers of Slurm, have worked with Google on in the past year, is being able to federate these resources together. All right. Okay, so sort of the last topic, talking a little bit about big data. Any of you guys using Hadoop on campus today or doing any big data projects? Okay, just one. So big data is all around us, right? I mean, obviously you've got lots of student data. I've heard some amazing presentations, like from our friends at UCSD working on their Student Activity Hub and Berkeley on their Berkeley Online Advising tool. But big data is all around us. We'll talk a little bit about how Google applied big data to collegiate basketball. And so in 2018, Google partnered with NCAA to come up with predictions for the March Madness basketball series. And first step in this big data problem, so we want to be able to do predictions on games. And so step one was to ingest the data. And so running pretty much a big ETL job, extract, transform, and load, taking decades worth of play-by-play basketball data, cleaning it up, massaging it, making it all fit into the data warehouse. That was step one. So you can think about how you've got potentially decades of research data, academic data, business data. Being able to bring that, consolidate it all into a data warehouse is sort of your step one. And we were able to do this in GCP through our enterprise data warehouse tool called BigQuery. So BigQuery is a NoSQL columnar database. It is lightning quick for searching. This is really a part of what powers, for example, your Gmail search. You think about how long does it take to search your entire Gmail inbox, potentially years and years of emails, versus how long does it take to do just find a JPEG file sitting in some folder on your desktop, right? If you've ever tried to look for a specific folder in your Mac Finder or Windows Explorer, it's like orders of magnitude of time longer than it takes to find an email in Google. So running ETL on Google Cloud We took data from the NCAA archives and another data source called Sports Radar, ran it through Dataflow, Cloud Dataflow, which is this tool which uses Apache Beam, which is an open source framework for ETL. Put that into cloud storage, which is our object store, and then we did a second round of ETL into BigQuery. And then second step, once you've got the data into your data warehouse, you're now able to analyze the data. So being able to ask questions in BigQuery. And focusing, so I assume some of you are basketball fans in here, right? What are factors that affect, outcomes of basketball games? Like, for example, what do you think is the scoring percentage in the first 35 minutes versus the last 5 minutes of a game? Yeah. Well, I actually think it gets a little worse because people are under pressure. Depends on the game, obviously, but on the whole, if a team is behind, they're going to start taking more risky shots to try to catch up and hopefully win. And so we looked at scoring percentages. We're able to look at factors like how many three-point shots were attempted. And then one of the things that Google did during the Final Four in 2018 was actually to create a commercial during the game based on that game's play-by-play action. And so being able to do real-time predictions on a game. And yeah, so these were the three factors that we looked at. And we actually created an ad during the Michigan versus Loyola game in March 2018. And this all happened it ran during halftime. So that meant you took 20 minutes worth of game time, had to come up with some predictions, send it to a rendering system, and this is the result. And it turns out that the outcome of that game was that Michigan did win 69-57 versus Loyola. And the number of three-pointers, I think, was off by 2 based on the prediction. So pretty close. Data tells stories. So other tools that are useful for you if you're going down this big data journey. So we've got this if you have data scientists on campus, which I'm sure you do, especially in your research groups, they all use Jupyter notebooks, which have been just shockingly successful in getting people to finally write comments with their code, right? How many of your computer science professors harped on you to comment your code? And now folks are actually doing that thanks to Jupyter notebooks. So we've got managed hosted Jupyter notebooks. There's a thing called AI platform notebooks, and it allows you to get into Google Cloud and just get into your Jupyter notebooks without having to spin up the infrastructure underneath that. And these are these are running on optimized VMs, for deep learning. They have GPUs attached, and they can also have access to novel accelerators like Google's TPUs, the tensor processing units that allow a incredible speed up versus other processors for ML. All right. Then things that we also have on offer for you all as faculty and staff, we have research credits available. And so if you've got research projects that need a little, maybe validation before you go to a funding agency like NSF or NIH, you can apply for a research credit from Google Cloud. We can provide some seed funding so that you can run a small scale experiment on Google. And then when you go out to, your researchers go out and seek a larger grant, they're able to have the evidence to say that, yeah, this thing works at a small scale. We now need the big grant in order to really scale up and see the results. For teaching classes, we have teaching credits available. So if you've got professors teaching things like databases, web dev, machine learning. So what I've found personally as a professor is that you have students coming into for me, I have students coming into my class, 40 kids every semester, and they'll come in with the hardware that they bring in their bags, anything from the latest and greatest 15-inch MacBook Pro, Core i7, this and that, to a crusty 5-year-old Windows 7 machine that if they're in, this kid's always sitting by the wall and always plugged in, because if they unplug their machine, it dies, right? So if I'm asking them to install a full stack software development set of tools, Visual Studio Code, Git, TensorFlow, that's not really an equitable learning environment, right? And then asking that kid with the underpowered laptop to go to the computer lab that closes at midnight versus the other kid who's just humming away on the 15-inch MacBook Pro, yeah, that's a hard nut to swallow. So enter the cloud. Now everyone's got access to, if they've got access to a web browser, they can get to SSH and they can run their code in the cloud. Everyone should hopefully be happy and have an equal chance of making an A in my course. Other stuff, training, we have lots of hands-on labs available for folks, and prepackaged courseware. So if your professors do want to teach a course in big data or machine learning and they don't have the course material already prepped, we've actually got a community of faculty from all across the world who have crowdsourced instructional materials so that anyone's free to reuse and share materials with each other. Yep, so I talked about research credits and yeah, Google Cloud certification. We're able to help you guys out with certification in case you do have folks who want to pursue this. We've got free training. And oh, by the way, this entire presentation is available online. You can access it through this bit.ly link, bit.ly/UCTech-GCP. So you can have access to this deck anytime. But yeah, so we've got courses available to help you pursue your certification. And yeah, that's kind of what I had to talk about, just in a nutshell, about Google Cloud as an enterprise platform for your academic institutions. Any questions? Yes. More appropriate workloads from an IT perspective, any web applications, anything that might need to scale up to the world. You can have any long-running jobs that or applications that might be running on VM infrastructure that's aging or about to go end of life. If you're looking at replacing your data center infrastructure versus going to cloud, the question I pose often to IT folks is, if you were to use a different metaphor, what does it cost to own a car versus use Uber or Lyft for everything? It depends, right? A car is a pretty big investment, and there's a lot of ancillary costs associated versus if you use Lyft, you're only paying for exactly what you need. And so in the case of any workloads that I'd say could be spiky, cloud is an appropriate place to put those workloads. Anything else? Going once or twice? All right, guys. Well, hey, thank you so much for your time. I don't want to stand in between you and lunch, so have a good rest of your day.